Hi, we are going into one of the most explored of the data profiling perspectives, the data distribution. So, data distribution is a univariate perspective of analysis where we focus on the values assumed by each individual variable. Naturally, the type of variable, being numeric or symbolic, determines the nature of the analysis to perform and constrains the application of the mining operations to perform ahead. But the principles behind the analysis are identical, and we will address each topic with numerical examples in order to illustrate the concepts. Our main goal by studying data distribution is to understand the dispersion of the collected values, their central tendency and variation. It's in this stage that we recognize incompleteness and unexpected values. In particular, we identify missing values, records without any value for one particular variable, and outliers, values that are unexpected when facing the rest of the values assumed by the variable, which sometimes correspond to the extreme values assumed by the variable. As expected, statistics play a fundamental role in this analysis, and its basic estimators are the ones used to reach our goals. In particular, the central tendency of a given variable measures the location of the middle or center of the variable distribution. Intuitively, it reveals where do most of its values fall. Central tendency can be estimated through its mean value in any of its forms. For example, the arithmetic mean expresses the average value in the set of values assumed by the variable, considering all values equally important, expressing a kind of a standard value for the variable. Other mean formulas can be applied, such as the weighted and the trim mean, with the last one being the best suited for very large datasets, with a considerable amount of outliers, unexpected deviations, or where we are in the presence of extremely skewed distributions. In this case, alpha% of the values are discarded, the ones more distant to the rest of the data, both the top and the bottom values. It is known that despite its variations, the mean value is sensitive to the existence of extreme values, outliers. Even a small number of outliers can corrupt the mean. Indeed, despite the trim mean deal with this situation, it is hard to choose the right alpha value without an earlier analysis of the variable data distribution. Fortunately, the median estimator is not affected by outliers. As you know, it corresponds to the value in the middle of the distribution, which means it is the value stored in the data that separates the higher half of the data from the lower half. To compute it, we just pick all values stored for the variable, including repetitions, and sort them in ascending order. Then we select the one in the middle of the list. If we have an odd number of records, it is just the value in the middle position, otherwise it is the average of the two values in the middle. Another possibility is to consider the mode, the most frequent value assumed by the variable. Naturally, we can have more than one mode, revealing the distribution as a multimodal instead of a unimodal one. The existence of just one or more modes reveals important information about the variable and its adequacy or not to some of the mining methods to apply ahead. Remember our dataset of iris flowers? Consider just the variable sepal length. The chart shows one dot per each value assumed by the sepal length variable. For example, there is just one record with 4.3, 3 records with 4.4, and so on. After computing its value, we are able to identify the mean value as 5.843, but the median is 5.8. In terms of the most frequent value, we just found one mode for the sepal length variable, a mode of 5.0. From these measures, we can perceive that the sepal length variable follows a skewed distribution, since the three measures are non-coincident. Indeed, the statistical distribution of a variable describes the probability of occurrence of each one of its possible values. They are usually translated as probability distribution functions as shown as histograms. Similar to the frequency chart for the sepal length variable, an histogram plots the frequency of the values assumed by a particular variable in a given dataset. The difference for the earlier chart is that usually values are aggregated in intervals called bins. So a histogram is just a bar chart where there is a bar for each bin of values and its 8 is just the frequency of the elements in the bin, the total number of records that assume the values covered by the bin. Naturally, the size of bins to consider have impact on the histogram. Larger bins have higher frequencies since they aggregate more values. Thinner bins have lower frequencies but show differences in consecutive values frequency. Indeed, reducing the bin size, which means increasing the number of bins, illuminates things that were not seen with fewer bins. Histograms are our attempt to name the distribution under the variable. There is much more to say about data distribution perspective, which is what we are doing in the next video. See you!